802.1Q Fundamentals and Configuration. Now that we understand how different VLANs on one switch segregate out a broadcast domain, we need to be able to allow that VLAN to traverse multiple switches such that VLAN 50 on my current switch can talk to VLAN 50 on an adjacent switch. That if I have my accounting PC on switch 1 and another accounting PC on switch 2, I need those to be able to talk. But then also a marketing PC on a marketing VLAN. That one's on switch 1, the other's on switch 2, I need to allow those to talk as well. So in order to do that, we need a method of tagging our traffic in that inter-switch communication, that inter-switch link, such that we can differentiate between which traffic belongs on which VLAN. So let's just start back up here with the VLAN, right? Is that in this picture we have over here the green VLAN and the purple VLAN, which is our accounting and our marketing. That when accounting wants to talk to the other accounting computer, the port here on switch 1, that is in the green VLAN. And this port here connecting switch 1 and switch 2 is what's called a trunk. And that it uses either 802.1Q or ISL as a standard for tagging within the header of that traffic which VLAN, the purple or the green here, that traffic is a member of, such that when accounting sends out an ARP for the MAC address of the accounting 2 PC's IP, that since it comes in on a green port, it goes out this trunk tagged as green. And then when switch 2 receives that broadcast on the green VLAN that's tagged as green, it sends it out all of its green ports. And same thing with the purple, is that it comes across tagged as purple and then goes out all of the purple ports, but not any of the greens. So this VLAN virtualizes switches into multiple logical LANs, and we needed a standard for this inter-switch communication, and that's where ISL and dot1Q came into play. ISL was Cisco proprietary method of tagging your VLANs in your inter-switch communication, and ISL, by the way, stands for inter-switch link. And it had a lot of problems with not being very efficient and having a much larger header. It's also legacy and not used anymore. You won't even have the option to use ISL as the encapsulation method on your newer switches, that it will only do dot1Q. However, on your older switches, you do need to go in and specify that you want your encapsulation to be dot1Q. That when we use DTP, Dynamic Trunking Protocol, some of these older switches will negotiate to ISL encapsulation by default. And we actually need to manually go in and change that. So let's talk about the dot1Q tag. Since the exam topics only include 802.1Q, that's really all I'm going to go into deeply here. So the 802.1Q VLAN tag is a 4-byte header field that's in our layer 2 header. And here it fits between our source address and our type and length, our TLVs in our layer 2 header there. The VLAN ID portion of that tag is 12 bits long. The standard range uses 10 bits, our 1092 and the 4096 here. I'm sorry, 1024 and the 4096 being with our 2 additional bits. And that the standard here, of course, is defined in IEEE's 802.1Q. That is what defines our header here. Now, trunking is referring to a switch port that is configured to transmit and receive 802.1Q tagged frames. By default on Cisco switches, a trunk is a member of all VLANs. It will accept all VLANs and it will transmit all VLANs, such that when you have a switch here, right, and you've got a host coming off here that's in the red VLAN, and you've got an inner switch link here that is a trunk, by default any broadcast sent from here will also go out the trunk. And same thing if we had a different VLAN over here, say the green VLAN. And you got your computer over here. When he sends a broadcast, the green will also go out our trunk. Now, dynamic trunking protocol, I mentioned that very briefly. This is what allows a port to become a trunk automatically, is when it can negotiate and detect that the other side of the link here is also a switch that has the ability to be a trunk. So it sends out these frames saying, I want to be a trunk, I want to be a trunk, and it tries to negotiate trunking. Now, it is considered best practice to turn off DTP anywhere and everywhere and only use static trunking to do switch port mode trunk. And you might have to do switch port no negotiate in order to disable DTP. That it poses a security hazard on your interfaces that are facing your hosts and your clients out there in the office. Bob's computer is actually receiving these DTP negotiation frames, and with some clever software you can go ahead and negotiate a trunk with the switch and be able to receive traffic to your machine that is not intended and is outside of the VLAN that you should be part of as an access port, that you've negotiated a trunk, so by default you are a member of all VLANs. Now the first command here, I did mention that we need to go ahead and manually specify our encapsulation as dot1Q. When you have the option of dot1Q or ISL, that you do need to specify one or the other before it'll allow you to go ahead and statically set the port mode as trunk. And this is only on switches that support ISL though, which has been phased out. So you'll only see dot1Q. Of course, like I said, that's not on the exam, but I wanted to make you aware that on some of these older switches that you're going to run into, you will have to specify your switch port trunk encapsulation dot1Q. So with dot1Q, it goes ahead and tags all of your VLANs, right? From 0 to 4095, is that it has that little item here, the VLAN ID, where this traffic, this frame is part of this VLAN. Now, to save on our overhead here, we have the ability to send certain traffic untagged that just does not have our 802.1q VLAN tag at all, and that traffic must be defined to be in a VLAN, and that is called our native VLAN. Any untagged traffic is considered to be part of the native VLAN. Now this is a configurable item. You can do switch port trunk native VLAN to define which VLAN ID is considered the traffic to be part of when it's received untagged, and which VLAN ID traffic will be sent across the trunk untagged. This reduces overhead. If you have 5 VLANs and approximately the same amount of traffic on each, then you have 20% less overhead because one of these doesn't need that 4-byte tag added into every single frame header. And that the native VLAN must match on each side of the trunk in order to function properly. It is possible to have mismatch native VLANs and to get things to work, but then that's how you get your VLANs intermingled and you end up with multiple subnets on the same broadcast domain, which just doesn't work and doesn't end well. So I want to go ahead and jump into a lab here and show you what the VLAN tag looks like when in a Wireshark capture here. So let me just go ahead and bring up GNS3. Is that we have our accounting PC 1 and 2 here, and our marketing PC 1 and 2 here. Accounting PC, or the accounting VLAN, is VLAN 30 and marketing VLAN is VLAN 50. I haven't done any configuration to these switches yet. I haven't even put the ports as access ports to their respective VLANs, and the actual VLANs themselves are not configured on the switches yet. However, I have put the IP addresses on each of these PCs here, which really are just routers that I'm using to represent PCs, so we don't need to do any configuration there right now. So let's go ahead and hop into our switches, configure our access ports here and our trunk, and do that on both switch 1 and 2. So our trunk on each of them will be Ethernet 01, and then our VLAN 50 will be Ethernet 00 on each, and VLAN 30 will be Ethernet 02 on each. So first let's go ahead and jump on over to switch 1. And just to show here, if we do show VLAN brief, we have VLAN 1, our default VLAN, and all of our ports are a member of VLAN 1 as access ports. So let's go ahead and configure our VLANs first here. We'll go config T, VLAN 50. And just to make sure here, VLAN 50 was our marketing VLAN, VLAN 30 is our accounting VLAN. So we're going to go name, marketing, and VLAN 30, name, accounting. And then let's go to Ethernet 00. It looks like actually Ethernet 01 is a trunk already here. If we take a look here, it is excluded from the list, and this is something that you might want to get used to, is the idea that when an interface is not showing up as part of a VLAN here in the show VLAN output, that it generally means it's a trunk. That only access ports in these VLANs show up here, and the command for showing those is show interface trunk. And that shows us that Ethernet 01 is encapsulated as ISL right now because it auto-negotiated as ISL on each side, since in GNS3 we're emulating an old switch here and they still support ISL on that. We see our native VLAN is 1. Now ISL does still tag its native VLAN, but we'll go ahead and reconfigure this here for dot1Q momentarily. Ethernet 01. Let's go ahead and do switch port trunk encapsulation dot1Q. Now just to show you here, our options are negotiate ISL and dot1Q. So our DTP would be negotiate. We can go ahead and just do dot1Q since we're going to set this as switch port mode trunk. And by default, our trunks are members of all VLANs. So just to check back here, we need Ethernet 00 in VLAN 50 and 02 in VLAN 30. So we'll go Ethernet 00, switch port access VLAN 50, and go interface 02. Whoops. Switch port access VLAN 30. Oh, and I just need to make sure switch port mode access. Let's do that over on Ethernet 00 as well. Switch port mode access. Excellent. Now if we go ahead and do a show interface trunk, we'll see that we have encapsulation of dot1Q and that it is trunking because there's a trunk mode of on rather than negotiating here. Now let's jump on over to switch 2 and we'll do the same configuration here. Config T, let's go VLAN 50, name, marketing, VLAN 30, name, accounting. So make sure I got those correct here. Marketing is 50, accounting is 30. Let's go exit, interface, Ethernet 00, switch port, trunk, encapsulation, dot1Q, switch port mode, trunk. Let's go ahead and do exit, interface, Ethernet 0/1. Oh, I just did the wrong interface here, didn't I? Yes, I did. 01 needs to be our trunk. 00 is an access port. Let's go ahead and go back into Ethernet 00 here and do, this is what this is made for. So we can go ahead and just copy that there. Do no switch port trunk encapsulation dot1Q. Do no switch port mode trunk. And no switch port trunk encapsulation dot1Q. We'll do switch port mode access, switch port access VLAN 50. Since we're on Ethernet 00, interface Ethernet 01, switch port mode, switch port trunk encapsulation dot1Q, and switch port mode trunk. Now let's go ahead and exit and go to Ethernet 02. And here we're going to go switch port mode access, switch port access VLAN 30. And we'll go end. Excellent. So now we've got this all configured here. Let's go ahead and take a look at what our tagged traffic will look like. If we just start a capture here between switch 1 and switch 2, there we go. We don't need an update. We got some spanning tree traffic. Now let's go ahead and run a ping between our accounting PCs here, 10131 and 10132. So if we jump on over to accounting PC 1, just go enable, and let's go ping 10132. It's very normal to miss the first one while it waits for an ARP reply. Now let's jump back over to our Wireshark here, and let's stop that so we can scroll up and take a look. So this, remember, this is in between our two switches on Ethernet 01 here. That if we go and take a look at our traffic, our broadcast here, that if we open up our Ethernet frame, our type is an 802.1Q, and our VLAN ID is VLAN 30 for our 10131. That our traffic here came in on Ethernet 02, which is part of VLAN 30, and then went out our trunk, and it was a broadcast, right? And it went out our trunk and broadcast out, such that when switch 2 receives it and it knows it's part of VLAN 30, it only sends that broadcast out VLAN 30 interfaces, which was Ethernet 02. So we have here our tag, our header item, our header field for 802.1Q saying the VLAN ID is 30. And then we end up getting our reply back on that. Now our unicast packets as well for our ping, our echo, and echo reply. For our 10131 to 10132, it's the same thing, that it's tagged as VLAN 30. Now if we go ahead and just briefly, to drive this home, go to Marketing PC 1 and ping Marketing PC 2. Now something I want to do here as well that I think will be fun is to briefly start a capture on this interface here as well, just to show that the broadcast does not show up there when we go ahead and do this capture. That let's go over to our PC1, our Marketing PC1. Let's go ping 10122. Very normal to miss our first one again. And then if we jump back over here to our capture, and it looks like that Wireshark did not actually decide to capture our traffic here, that I made it a little angry, and it decided to stop and is not running any kind of capture anymore. Alrighty, well, you just have to take my word for it there that you did see the 802.1Q tag here, and that this is what you would end up seeing if you capture some traffic and you see traffic like this. You know you're looking at a trunk, and if you set a trunk as a span port, that's switch port analyzer port, to where you can go ahead and take that traffic and duplicate it out another port to have it mirror that, so that you can usually do an IDS, perhaps an intrusion detection system, to take in all of that traffic and find malicious traffic or unusual traffic, and it'll all be tagged for your VLAN as well, so you can separate out that traffic. Now, just like the other sections, let's go through a couple of practice questions before we end off here. First up, what is the name of the protocol used to negotiate trunking on a switch port? Is it VLAN trunking protocol? Is it Link Aggregation Control Protocol, LACP? Is it Dynamic Trunking Protocol, DTP? Or is it Extensible Authentication Protocol, EAP or EAP? And you should know by now that it is C, Dynamic Trunking Protocol, DTP, that allows two switch ports that are directly connected to negotiate themselves to a trunk, rather than just being an access port to know each other is a trunk and to start sending tagged traffic with the appropriate encapsulation. How many bits are available for representing a VLAN ID in an 802.1Q tag? You might recall that the .1Q tag here is 4 bytes. And within that 4-byte field here, that we have 12 bits available for our actual VLAN ID to make up 4,096 possible combinations. So our answer is C12. Now I hope this has been informative for you. Now I'd like to thank you for viewing.